in the first slide itself. So Mr. Title as an enjoy. Start with the cloud equation for the day. Who can solve this? Actually, I made a mistake. I just went through, so you know the answer by now. My cloud plus your cloud is a dog and a cloud. Right? So today you saw the cloud definitions from various perspectives, from end users, from IT vendors, from the network vendor. So the cloud is getting darker and darker now as it goes along. So this happens with any evolving IT technology. There is so much hype to it. It suffers the hype, and that's where it becomes much more confusing in the initial stages. So I have to just follow up and then add a bit more to the confusion here with my definition. A pool of IT resources capable of hosting your applications. Okay, so this is where we started. This is basically the data centers, right? And our IT industry is not any less earlier than the women's fashion industry. So we got to add a bit more motor to it. Scalable, that's what we added. And what is this scalability all about? What is the biggest machine that is ever invented by the humankind? The internet, right? Dr. Leon was rightly pointing out. So the internet, though it's billions of computers, it just behaves as one single big entity. And anything as simple as a URL will let you enter into this machine and you go around. You don't know the computer that you are talking to is in which part of the world. Is it clean or dirty? Is anybody spooky sitting next to it? You don't care about it. So we're talking about infinite scalability here. Okay, so that's the differentiator. And something that's built by consumption. Okay, so this is a predominant model that cloud is, the business model that cloud is going to try, though it's not going to be the only model. Right? So this is pretty much like the utility that the previous presenters talked about. Okay, so that's putting things in perspective. That comes the next cloud equation. Anyone want to solve this? Hopefully. Just trying to make things clear to you. So moving forward, what I'm trying to do here is that, pretty much like what Dr. Leon said from the user's perspective, right? So I'm going from an architect's perspective, a designer, a cloud progress perspective, look at how things are and how it is going to, impact my life, how it's going to change the way I do things. Okay. So a couple of years back, the little girl out there tried to understand my job. What do I do? Okay. And of course, she has seen me sitting at home and drawing architectures. A whole lot of it. And then the question was, so what do I do? And I have to give a simple answer. I have to sell IBM software. And then comes the question, what a software is. And you all know the difficulty in explaining these kind of things to the children, right? So if you haven't experienced, go home tonight, talk to your grandma, and try to explain what is cloud computing to them. Okay. So, CD software, oh yes, there is something that is available in the CD. Hardware is your computer. That kind of definitions come along. So she put up everything and connected the dots, drawing boxes to sell CDs. That's the definition. Okay, that's pretty much like the Obeng, sitting and selling pirated CDs in the neighborhood. But I don't know whether I should be upset because probably he's making more money than me. Right. So what's going to happen? These are the kind of boxes that I draw, right? Architectures, web servers, app servers, middleware, a whole lot of layers. The only complex thing that I could see here is, the kind of cloud with some dead people on top of it. So anyway, though it sounds as simple as that, I have my challenges, right? So I'm going to list my challenges here. Challenge number one is the art and science of drawing boxes. So it's not just anyhow randomly drawing boxes. There is some science and there is some art to it. So what is that? Software engineering principles, right? First, this is easy to remember if you memorize this acronym. It stands for functionality, usability, reliability, performance, and scalability. The world of software engineering is all about attending to these forces. Right? This is what architects do, and this is where we spend years of research trying to understand how to design the systems for these forces, and that's where we lose head. So if you look at it, the top two are pretty much art, functionality, and usability. Right? Why I'm saying that is that if you don't want to use functionality itself, until today, nobody knows how to estimate how much time and effort it's going to take to develop a particular function. Right? So you don't know. Even the users, if you want to ask them what is it that you want your system to do, they probably don't have a clue either. Okay, so that's our piece in the functionality side. Usability, definitely. But the last three, reliability, performance, and scalability, there is a big science behind it. Okay, that's where the architects get paid. Okay, so refresh what is the reliability is all about. Right? This is what we talk about resilience. Obama like can do servers that can withstand failures in the hardware, operating system, application, various layers. So that's reliability. We talk about performance, right? How much transactions can the system turn around in a particular second? How much is the response time to the users? Scalability is, horizontal and vertical scalability. How do I scale the environment as the demand comes in? So a lot of science behind this, and this is my challenge. Every time I design a system, I have to consider all these things. Okay. Challenge number 2 is automated provisioning. Okay, so I have my boxes drawn up. I have put my science in there, and how am I going to deploy it and make it available to my users? So I use the term provisioning here. I heard this term from the previous presentations also. It's a fantastic term derived from the telco industry, right? So once again, Dr. Leon pointed out the telco industry is a real cloud application. Like when you are talking in the wireless 3G phones, you are not setting up your own GSM network, right? All that you do is to subscribe it from a telco. And what most of us don't know is that when you go and ask the telco for a 3G line, there is something called technical feasibility that's happening behind. So the telco goes and says, okay, this user comes in now with so much bandwidth requirement, so much voice requirement, can my network cater to this? And then they increase the capacity if needed, and that is what they call as provisioning. So pretty much we want the IT world to function in this way. And automation is a very important thing because we never had seen automation in provisioning so far in the IT industry. And there is good and bad automation, right? We talk about bad automation. A couple of days back, I wanted to go to a toilet in a building. So I walked through, there's a sliding door, automated sliding door, and the door failed to recognize me. So I was standing there, moving there, doing some disco. The door is not impressed. That's bad automation. So finally I had to go press the button somewhere and it opened. And then I went into the toilet, into the stall, and started doing what we normally do. And then suddenly from behind, huge sound came out. Then I looked at it, it's automatic flush. Too sensitive, bad automation. So, okay, then when I zoomed, once again the flush went on. So I was like, no, can I be the one to decide when I'm done? So, bad automation again. You walk out, you see these taps dispensing waters. Once again, you see bad automation over there. You put your hands there, you put a spoonful of water, and then that's where it stops. So you are like positioning yourself under the tap to get more water. All bad automations, right? So we are looking at good automations in provisioning because typically what happens is that when I draw my boxes and give it to the guy who delivers, the guy takes about 2 to 3 months setting up the environment, depending on how complex it is. And that's not going to work in the new business models. Management, once again, this is a topic which most of us have touched. So it's very important that once the system is up and running in the production, we keep monitoring how the load comes in, and then when the load shoots up, we have to be monitoring it so we can respond to that particular event. So it is in traditional environments this is more important, but in cloud environments it's become very critical because in the cloud environment you don't start with a big system ahead. You only start with what is needed at that point in time. Okay. So these are my 3 challenges, right? And then I have to see what kind of solutions being offered to solve these 3 challenges. So just to summarize them, you can see here is about life cycle in a cloud solution. So once again, we saw simple to complex life cycles in the previous presentations. But what you have to remember and take away is challenges in designing, right? So which means I have my boxes in the paper. So I have to have some place where I can draw my boxes and follow my boxes, and then provision the environment, provision the cloud, and once it's up and running, manage. Very simple, right? And I put an out here called raising levels of abstraction because as the technology goes further, we are looking at things at a higher level. those challenges of object-oriented analysis, design, all those things are still there when you are developing applications. But we know what they are all about. But moving forward, this is what the major life cycle phases that we need to kind of do. Okay, so solutions-wise, yeah, I come from IBM, so I have to see what IBM is offering as a solution. Drawing boxes